Hello, everyone. Thank you for joining us for this virtual portion of the Milan No-Till Field Day. My name is Shelly Pate, and I'm a PhD student at the University of Tennessee, and I work with Dr. Heather Kelly. And today I'll be talking to you about taproot decline and other soil-borne pathogens. I wanted to start by briefly going over the disease triangle, which highlights factors that are important for a disease to actually become significant enough to affect your yield. And for this to happen, obviously the pathogen must be present in your field. The environment must be conducive for disease development, but also a host plant must be susceptible to disease development. And our final factor is timing. So in regards to host growth stage and when disease develops will impact whether this disease that's present in your field will be able to actually affect yield in the long run. So considering all the different factors of the disease triangle and assuming that they're all present and working together at the same time in your field, you could see a number of different soybean pathogens throughout the growing season. Some of those could cause foliar diseases or stem diseases and could be caused by a number of pathogens such as bacterial, viral, fungal, or nematode pathogens. However, today we're primarily going to look at seed, seedling, and root rot diseases and diseases caused by nematodes. So mostly with our seed, seedling, and root rot diseases, those are caused by fungal soil-borne pathogens. And our nematode pathogens are plant symptoms that are caused from damage to the root system by microscopic roundworms. Looking at our first common soybean pathogen in Tennessee, we're going to be talking about Phytophthora Root Rot. When looking for this disease, most of the time we'll see seed rot as well as pre and post-emergent stamping off. As far as disease development, this disease is more commonly seen in the early season during the early vegetative growth stages, but really infection can occur at any growth stage. Our management options, which is true for the majority of most fungal soil-borne pathogens, is to use resistant varieties, utilize fungicide seed treatments, as well as make sure we're having improved drainage and tilling in our field environments. Sudden death syndrome is another soil-borne pathogen that, similarly to Phytophthora root rot, can also cause root rot. However, this pathogen is also known to produce a toxin that can cause these small yellow spots on the leaves that you can see on the right in this picture. Those leaf spots, once present, will progress into interveinal chlorosis, which is what we call the yellowing, and then further progress into necrosis, meaning anywhere that those yellow spots are, that plant tissue will begin to die and then turn brown. The leaves at this point may defoliate prematurely, but what's a real key characteristic of sudden death syndrome is that once those leaves defoliate, they will remain attached to the petioles. Infection occurs typically early in the season, meaning that that disease moves in from the soil into the root system of the soybean, but usually we won't see foliar symptoms appear until later reproductive growth stages of the soybean. Again, management options are varietal selection, utilizing that fungicide seed treatment we talked about previously. Delaying planting here or even choosing an earlier maturing variety is a very good option. And also making sure in our fields we're improving that drainage, reducing soil compaction, and reducing soybean cyst nematode populations with crop rotations. And I just want to touch on here that soybean cyst nematode is classified in the nematode category of plant pathogens, and when it's present with sudden death syndrome, we see that they can form a synergistic relationship and really work together to increase disease in our fields. The last two pathogens we've discussed were soil-borne pathogens that primarily cause symptoms on the root system. However, now we're going to talk about a soil-borne pathogen which causes a disease that is primarily observed on the stem of the plant. With southern stem canker, we'll see small brown spots on stems near the lower nodes of the soybean, which can develop into cankers that are usually several inches long on the stem. However, when looking for those cankers, we will only see them on one side of that stem. If we were to cut open the pith under that canker, we would see that the vascular tissue would be brown. And we would also notice that in the field, our leaves begin to yellow between the veins and later die. But instead of prematurely defoliating, those leaves will remain attached. Symptoms of this disease usually show up around reproductive growth stages. And again, when looking at management options, variety selection, again, very important, but also using crop rotation out to things such as corn. Charcoal rot is a soil-borne pathogen that we typically see thrive in warm and dry seasons. This pathogen can cause an overall loss of vigor and cause small leaflets that will just turn yellow, wilt, and end up dying, but remaining on the petiole. When we split open that stem and observe the vascular tissue, we can see that plants that have been infected with the pathogen causing charcoal rot will have black mycosclerotia develop on the vascular tissue, and that's a really good example of that on the picture to the right, where in the root system on the left you can see the development of those black mycosclerotia, and on the right a healthy vascular tissue. Symptoms, this is another late season pathogen where we're only going to see symptom development usually in the later reproductive growth stages. And again, looking at management options, I cannot stress this enough, variety selection is very important, but also making sure we're using cultural practices to avoid stress and retain soil moisture with this pathogen. We can also consider rotating out again to prevent the re-inoculation of soybean year after year by rotating out to another crop, again, such as corn. Now moving into taproot decline, which is arguably maybe my favorite disease out of this whole presentation, but I guess that's because this is the disease that the majority of my PhD research revolves around. Taproot decline is caused by the pathogen Xylaria necrophora. It's a fungal soil-borne pathogen, and we classify this as an emerging pathogen, meaning that we have only taken note of this and think that this pathogen has only been present in Tennessee for the last few years. It's only been observed in a number of neighboring southeastern states. What's concerning about Xylaria necrophora is that historically, fungi in the genus Xylaria have been saprophytic wood rotters, meaning that we have never seen a Xylaria genus fungi be pathogenic in our crops. And this is especially concerning since we're seeing this move into soybeans, which is one of the top producing row crops in Tennessee. I wanted to save this fungal soil-borne pathogen for the last fungal soil-borne pathogen in this set because I wanted you to be aware of the signs and symptoms of other common soybean pathogens in comparison to this one, because this pathogen can be easily confused with other soil-borne pathogens due to its symptom similarity. So when looking at taproot decline, we're usually going to see yellow interveinal chlorosis and necrosis, which is common with other soybean pathogens. But what to look for as far as taproot decline is this chlorosis will develop in the lower canopy and then develop throughout the upper canopy. So usually we'll see these small yellow foliar lesions, which we can see in this disease progression chart for foliar symptoms below at the bottom of the slide. And then that'll move into total leaf chlorosis. And then we can see that that develops into those necrotic lesions where the leaf tissue starts to turn brown. At this point, the plant will usually kind of start to die off. The leaves will begin to crinkle and roll up, and the plant will begin to wilt. Until finally, in severe cases, we'll see seedling death or even plant death in the later reproductive growth stages. When we see these foliar symptoms in the field and we go out and say, oh, there's something wrong with this plant, when we look down at the soil line, we usually see these dead man's fingers, which the term for that is stromata. It's the reproductive structures of this fungus, and you can see on the right that the stromata will look like those dead man's fingers and will be found on neighboring crop debris. If we were to dig up the afflicted plant and split open that stem, we would see that in the pith there would be white mycelial growth, which is really characteristic of taproot decline and really sets it apart from some of these other soil-borne pathogens that also cause vascular staining and vascular tissue damage. We need to make sure that we're digging up these afflicted plants, splitting the stem, and looking for white growth in the pith, because due to these symptom similarities, taproot decline often goes misdiagnosed or unnoticed, and we're really trying to get a grip in Tennessee on how wide disease development has spread in West Tennessee. So if you dig up a plant and you see these symptoms, please give us a call, because we would love to come out and take some samples and use those in our lab for our research. Again, disease development, we have that soil-borne pathogen moving into the root system early, but then we won't see the foliar symptom development until usually early to mid-reproductive stages. And in high soil concentrations, Xylella necrophora can actually cause seedling death. So that, again, can be easily confused with something like Phytophthora Root Rot, which can cause seed rot and pre- and post-emergent stamping off. Again, for our management strategies, since this is an emerging pathogen, there has been very little research done up until this point, but we do have some information as far as varietal selection, and we do know that rotating out to different crops can help decrease the amount of Xylella necrophora inoculum that we're putting back into our soil system every year. Moving away from fungal soil-borne pathogens and looking at soybean cyst nematodes, these are microscopic roundworms that are very common in Tennessee soybeans, and in many fields there will be no visible symptoms as far as foliar symptoms, but you may observe slow canopy closure, stunting, yellowing of the edges of the leaves, poor stands, and decreased yields overall. Nematodes can survive in the soil. They burrow into the root cells and they deprive the plant of nutrients and wound the site for other pathogens to enter, which is why I mentioned earlier that soybean cyst nematode is commonly associated with causing a synergistic relationship with sudden death syndrome, meaning that when those two pathogens are present at the same time in a field, you're going to have increased disease severity. For SEN, it's really important that we're sampling for soybean cyst nematode in the fall, and you can do that by taking soil samples and sending them to us, and we can have those screened for you for a small fee. Looking at resistant varieties again, and again, utilizing crop rotation and cultural practices that can reduce plant stress. So today we've covered a lot of different soil-borne pathogens that are known to cause soybean diseases in Tennessee. I know it's a lot to kind of keep separate and keep up with, but if you're observing any of these symptoms in your field, what's a really good tool to help you differentiate between diseases before giving us a call to come out and observe is that you look at our guides at utcrops.com on soybean seedling diseases and soybean pod, stem, and root diseases. This is where you're going to find a majority of what we covered today, and again be able to view pictures and further information on specifics regarding each individual disease. If you have any questions about the presentation today, or especially if you think you have taproot decline in your field, please do not hesitate to email Dr. Heather Kelly or myself. You can also keep up with us on Twitter, and you can specifically follow my Twitter at the handle below and keep up with my research. Thank you for listening today.